All right, let's take a look at section 4.4, using corresponding parts of congruent triangles. All right, so if you know two triangles are congruent, then you know that every pair of their corresponding parts is also congruent. So once we proved, yesterday we worked on proving two triangles congruent by using side, 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 angle, side, angle, or angle, angle, side. Once we prove those triangles congruent, then we can also say that the other corresponding parts are congruent. So we proved three parts of the triangle congruent in our last lesson. Now we're going to prove, we can say that the other three parts are congruent. The abbreviation we're going to use here is CPCTC. Corresponding parts of congruent triangles are congruent. So if you look at these two triangles, why are they congruent? Well, we look and we have an angle here and an angle here, an angle congruent to an angle. So these two angles are congruent, these two angles are congruent. And now we have segment BC congruent to CD. This segment here, this side of the triangle is part of both triangles, so by the reflexive property it's congruent to itself. So these two triangles are going to be congruent by angle, angle, side. So can we conclude that KC is congruent to AB? And the answer is yes, because we proved our triangles congruent, then the other parts are also congruent. So if the triangles are congruent, then all their corresponding parts are congruent. Since we proved them congruent by angle, angle, side, we can say that KC is congruent to AB by CPCTC. Corresponding parts of congruent triangles are congruent. So let's take a look at our first proof. Okay, so in this proof is a little different. We're trying to prove that angle C is congruent to angle E, where in our last lesson we were proving that two triangles were congruent. So let's take a look at how we would work this proof. Everything should work the same except for the last little bit. The first part is we're going to start off with our given statement. So BA is congruent to DA, and that is given. So then it's marked up here. If it wasn't, we'd go ahead and mark it. And the next we have CA congruent to EA. Also given. So that's two sides congruent to two sides. So next we look at our picture. We notice that we have a pair of vertical angles that are congruent. So we need to name those. So we'll say angle, and I'll just describe it. I'll just start with C. Angle CAB is congruent to angle, and if I start with C, I got to go to the congruent part, which is going to be EAD. So these two angles are congruent, and the reason why they are vertical angles. So vertical angles are congruent. So that leaves us with step 4. So now we have a side, side, and a side. So that's enough to prove our triangle is congruent. So now we have to name the triangle. Triangle, we can use the same letters we use here because those were in corresponding order. Triangle CAB is congruent to triangle EAD. And our reason is going to be side, side, side. So once we proved our triangle is congruent, then all the remaining corresponding parts are congruent. So now we have enough to say that angle C is congruent to angle E. And the reason is going to be corresponding parts of congruent triangles are congruent. So CPCTC. So everything, the first 4 statements were the same as we did in the last lesson. The only thing different here is we're proving the other remaining parts. So this could have said prove angle B is congruent to angle D, or prove CB is congruent to ED. Those are the 3 remaining parts. So any of these could be been proved by the same method, by first proving our triangle is congruent. So let's take a look at the next one. Example 2. We're looking for, we've been given that AB is congruent to AC. It's been marked up here. And M is the midpoint of BC. Those are the 2 things given. So we're trying to prove that angle AMB is congruent to angle AMC. So work this one out. Pause the video, come back and check your answers when you're done. All right, so let's look here. We've got our given statements, AB congruent to AC. It's marked for us. M is the midpoint of BC. And so because it's a midpoint, that means that it's going to break it up into two congruent halves. So we mark our halves here, and so we're going to write down what's congruent. So the length of BM is congruent to CM, because M is the midpoint, halfway through. So that reason is that is definition of midpoint. Then we have to recognize that the segment AM is congruent to itself by the reflexive property. So now we have three sides congruent to three sides, so we now can prove our triangles AMB congruent to triangle AMC by side, side, side. Now that we've proved that they're congruent, we can now say that angle AMB is congruent to angle AMC. And the reason why these two are congruent is because of the following triangles were proved congruent, so therefore all their corresponding parts are congruent. Now, what measure would this be? If this is going to be a straight line and these two are congruent, what angle is going to be supplementary and congruent? And that should be a right angle. Both of these are right angles here because 90-90 gives us 180. All right, let's take a look at this next one. So, Thales, a Greek philosopher, is said to have developed a method to measure the distance to a ship at sea. He made a compass by nailing two sticks together. While standing on top of a tower, he would hold one stick vertical to the ground, and the other he would hold out till he could see the ship. So once he could see the ship, with this compass setting, he could rotate it around to see the tree at point L. And since he can measure the distance between the ground here at the base of the tower to the tree, he figures that these two distances should be the same. So what we've been given is that this TRS is a right angle perpendicular to the ground. They're both right angles. And that RTS, okay, right here, this angle here is going to be congruent because we have not changed the measure of his compass. So we're trying to prove that RS is congruent to RL. So in order to do that, we've got to first prove our triangle is congruent. So let's look at this. We're given that RTS is congruent to RTL, and that's given. Now it says reflexive property. Well, remember, reflexive property tells us that we have a segment congruent to itself. So TR congruent to TR. Now it says that these are right angles. And so remember, when we're dealing with right angles, we also have to tell that they're congruent. So we'd have to say that angle TRS is congruent to angle TRL. And that would be that all right angles are congruent. So now we have an angle measure. We have another angle measure. We know the side length here is congruent to itself. So we have enough to prove our triangle congruent. So triangle TRS is congruent to triangle TRL. And the reason why is going to be angle, side, angle. Angle right here, side in between, and angle down here, congruent to angle, side, angle. So sometimes you're going to be asked to fill in only what maybe the statement or the reason. Sometimes you're going to be asked to fill in both parts. So now let's look at something different. This time we're trying to prove a definition. So in order to prove a definition, we have to first figure out what does the definition tell us. So if KQ bisects JP, that means that KQ is going to cut JP in half. Okay, remember, to bisect, you're cutting in half. So if they're going to be cut in half, that would mean that these two segments would have to be congruent. The segment JM and PM. So we need to figure out how we can prove that these two segments are congruent. If we can do that, then we can say that KQ does in fact bisect JP. So in order to do this, we have to first prove our triangle's congruent. So let's look to see what we've got. They give us the first statement is JK parallel to QP. That is given. And so the next step, let's see what we know because of the lines parallel. Now in the past I've said that anytime we have a parallel lines, 9 times out of 10 it's going to be we have a pair of alternate tier angles. In this case, because we have our parallel lines here, we have two transversals, we're going to end up with two pairs of parallel of alternate tier angles. So this angle K is going to be congruent to angle Q, because these are alternate tier angles in parallel lines. Since JP is also a transversal, that's going to make that this angle right here, angle J, and angle P congruent. So that's what we have to do, is name those. So we're going to say angle K is congruent to angle Q, and angle J is congruent to angle P. And we just said these are alternate tier angles. So alternate interior angles are congruent. So we put this in one statement, therefore we don't have to put down two different statements and write the alternate tier angles twice. So we have an angle measure, we have an angle measure, we need to see we need to find some side length that we know. So, and that's one of our given statements. So JK is congruent to PQ. And this is given to us. So now we have enough to prove our triangle's congruent. So as you look here, we've got these, we have two angles on a side, so we can prove it true. We can prove our triangle's congruent, so we're going to say triangle KMJ is congruent to triangle, since we started with K, we got to go its matching part, which would be Q. We went to M, so M is in the middle, so we go back to M, and then we do P. And our reason is going to be angle, side, angle. So the reasons why we're using statements number 2, it's got a congruent statement in it, it's got two of them, that's two angles. And then we're using statement 3, which has got this segment here. So when you see a set of parentheses on some of these problems, they're just telling you these numbers represent the statement that they're getting the congruent statement from. So now we can say, since our triangles are congruent, now we have enough to verify that JM is in fact congruent to PM. And our reason why is going to be corresponding parts of congruent triangles are congruent. So then now let's take a look at our last one. Number 6. Sixth statement here is what we're trying to prove. Since we have that these are congruent, now we can say that KQ bisects JP. And the reason is going to be definition of a segment bisector. So this is how you would prove a definition. Okay, instead of just proving another side was congruent, we're proving a definition this time. So we had to use everything we did before, we had to use it to prove that this KQ does in fact bisect JP. All right, let's take a look at our last one. All right, so now we're trying to prove that S is the midpoint of BK, this line segment here. What we've been given is we've been given that BA is congruent to KA, and that BE is congruent to KE. So in order to prove that S is the midpoint, we first have to either show that it's a part of two congruent triangles. And for the information we've given, we haven't proved enough yet to prove that either these two triangles or these two triangles. So we have to either prove that these two triangles are congruent or that these two are congruent. But right now, all we can prove is that the triangles in the bottom half and the top half are congruent. So let's start with first proving one of our triangles congruent. We're going to try to prove the top AKE is congruent to ABE, this top triangle and bottom triangle. So let's start writing our given statements. BA is congruent to KA, and BE is congruent to KE. So I'm going to combine these two in the first statement. This is going to be given. Now, the next statement, since these two are congruent, what I can do is I have the reflexive property. I can say that AE is congruent to AE, and that is reflexive. So what we're first looking at is the two triangles, the top and the bottom. So this side is congruent to itself. Then now we can say that triangle AKE is congruent to triangle ABE. And our reason is going to be through side, side, side. Say that would be through statements 1 and 2, since we combined one of our statements. Now, so this triangle is congruent. So because of this, we know the following. We can say that angle E is congruent to angle E. This angle right here, BES and KES are congruent. We would also know that this right here, BAE, is congruent to KAE. So at this point, we can choose whichever triangles we want to solve for. So let's solve for the larger triangles on the right. So I can figure out these two are congruent. Then I can say that these two segments are congruent. Therefore, it would be the midpoint. S would be the midpoint of BK. So we need to write a statement of congruency since we know these are true here. So we're going to use the ones on the right. So we're going to say that angle KES is congruent to angle BES. And the reason is going to be corresponding parts of congruent triangles are congruent. So we said these two are congruent. So now we have a side length and an angle measure. And if we're trying to prove these two triangles congruent, we can also look at the segment SE. SE is a part of both the top and the bottom triangle, two triangles on the right. So SE is going to be congruent to SE. And the reason why, again, is going to be reflexive property. Go back and put property up here. Okay, so now we have this side right here is congruent to itself. So now we can say that we have two triangles congruent again. So we can say triangle KES congruent to triangle BES. And our reason is going to be side, angle, side. Now this is using statement 1, statement 4, and statement 5 to prove that this is true by SAS. So once we've proved that these two are congruent, now we can say that their corresponding parts are congruent, which means we can say that SB is congruent to SK. And that's going to be by CP, CTC. And so since these now are congruent, we've shown now that S is in fact, it does cut this in half. And so we can say that these are going to be congruent, and so therefore this is the middle. So we'll say S is the midpoint of BK, and our reason is the definition of midpoint. So this is how you would prove a definition again, but this time we had to do it twice. We had to prove two different triangles were congruent. So we can use their corresponding parts to help prove this definition. All right, this concludes lesson 4.4, corresponding parts of congruent triangles.